in the previous session, so this is the continuation to the previous session. On 22nd Jan, we discussed these concepts. Okay, let me just make some adjustments. Okay, hang on one second over here. Okay, now this is what we discussed in the previous session. This is what we had discussed. So we discussed about the EC2. What is EC2? EC2 stands for Elastic Compute Cloud. The purpose of the EC2 is that it gives you the resizable compute capacity in the cloud. If I say resizable, this means that you can change the specifications of a virtual machine. Now, what's a virtual machine in AWS context? A virtual machine is called an EC2 instance. A virtual machine is called an EC2 instance. It has some amount of RAM, storage, CPU, GPUs, etc. It has some compute capacity. So this thing, a virtual machine, it has some compute capacity in form of RAM, storage, virtual CPUs and GPUs, etc. So this is my compute capacity. Now this compute capacity can be changed whenever you want. You can change this compute capacity. It can be resized. And so a virtual machine is nothing but it has some compute capacity. From AWS perspective, we name it as an EC2 instance. What's that? It's an EC2 instance. Upon the instance, okay, so one thing I missed out. The instance's compute specifications. How much RAM, storage, virtual CPU, GPUs will be given to you. It's being defined by the instance type that you have. It's been defined using the instance type. So what's instance type? It's nothing but it's a virtual representation of the underlying physical resources. So what's the amount of RAM, storage, virtual CPUs, GPUs you have? Depending upon that, or depending on the instance type that you choose, you get the amount of RAM, storage, or other compute capacity. For example, if you choose T2.micro as instance type, which gives us one virtual CPU, it consists of 2.5 gigahertz of Intel Xeon processor, 1 gig of RAM, and 8 gig or 30 gig of storage, depending upon whether it's a Windows or Linux instance. Fine. And upon this virtual machine, you can deploy some applications, scripts, and software. And most importantly, you have to run an operating system because you need to have an operating system upon which you can deploy some applications, services, and software. We package all these things, the software components, in the form of AMI. It stands for Amazon Machine Image. What's an AMI? It stands for Amazon Machine Image. It consists of the operating system, whether it's Linux or Windows, applications, software, and scripts that you execute as a package and install everything upon the instance. So you have to have the AMI or the Amazon Machine Image. So these things were discussed in the previous session. It's just kind of a refresher for you. Then I discussed the concept of IP addresses. Now, why we need the IP addresses? So that our virtual machines or the instance can communicate on the internet. Fine. There are three different types of IP addresses we have. One is private IP. It facilitates internal communication, right? So if two different instances or the virtual machines, if they want to talk to each other internally, they will be using or they should be using the private IP. For example, if you see my screen diagram that you have, we have an AWS cloud, we have instances A and B. They want to talk to each other. They want to communicate with each other on the same network. So in that case, they'll be using the private IP. Right? Now the private IP fall in the following three ranges. So 10.x.x.x, 172.16.x.x, up to 172.31.x.x, 192.168.x.x. X denotes any number between 0 to 255. Fine. So this is the concept behind using the private IPs. Then we have the public IPs. The purpose of the public IP is that it exposes your instance to the internet, which means that if your instance want to communicate with the internet resources, for example, if you see this diagram, we have an EC2 instance. So let me just label it. This is my EC2 instance in the AWS cloud, and it wants to communicate with the resources on the internet. It wants to communicate with the resources on the internet Internet is the biggest public cloud. So in order to expose an instance to the internet, it's very, very important that you assign it a public IP. If you don't assign the public IP to the instance, it remains secluded or isolated. In that case, it can communicate with any other instance in the same network, but it will not be able to access the internet. So you ought to assign the public IP address to the instance so that it can become publicly accessible. What are the ranges that the public IP falls into, except the private IP address ranges? So these are the 3 different private IP address ranges. So the public IPs will not fall in any of these 3 ranges. Also, the loopback IP, which is 127.x.x.x, which is used for troubleshooting. We don't use the 127 IPs anywhere because they're purely used for troubleshooting or debugging. Now, who assigns the public IPs? It's either AWS. AWS can automatically assign your instances the public IPs as soon as they're being launched. Or you can bring your own IP, which means that you lease the public IPs from these service providers and use the same public IPs on AWS. But in that case, you have to pay for that. Why are you going to go for your own IPs? Because you want to get some uniformity across your data center infrastructure and AWS infrastructure, both. Now, public IP, even though it's very important if you want to deploy some websites upon the instance, there's one downside of the public IP. That is, it is not static in nature, which means that as soon as you restart the instance, you stop and start the instance, the public IP address changes. Okay? So if you stop and start the instance, the public IP address will change. Now, this is a big downside in case if you have some websites deployed upon the instance. For example, this is the thing we discussed in the previous session. If, for example, if you have a virtual machine or the instance upon which you have deployed a WordPress site. Now, how those external users will access your website? They will type your domain www.xyz.com. The DNS servers will convert that xyz.com to the public IP address behind the scenes, and hence the external users will be able to reach your website. Now, if this instance is restarted automatically or manually, this means that you have to map your domain every time the instance restarts. Otherwise, your external users will not be able to access your website. So, in this case, the public IP address has a major downside. It changes every time the instance restarts. To fix this issue, you make use of the elastic IPs. They're nothing but they're the same as public IPs, but they're static in nature. They have the same range as public IPs. And who assigns them? The customers or the solutions architects. Fine. So these are the 3 different types of IPs we have discussed in the previous session. I just refreshed those things. Private, public, and elastic. Okay. Then we discussed the concept of AMIs or the customized AMIs. How to manufacture the customized AMI? You launch an instance using a public AMI. Okay. So let me just do one thing. Let me just log into my AWS IAM console real quick and just discuss with you how this works for you. So let me sign in. Okay. So let me sign into my AWS IAM console real quick so that I can show you exactly that what exactly I'm talking about. Guys, by the way, at any given point of time, if you have any questions in between, please put the questions in the question window or just raise the hand so that I can answer your question. I can put you off the mute, you can speak, and I can answer your question. Okay, so I go to the EC2 under the compute section. Let's go there. And once I just go to the EC2 under the compute section, from here I can launch my virtual machine or my EC2 instance. Now this is the EC2 console, EC2 management dashboard or EC2 dashboard or EC2 console, whatever name you want to give it to this page. From here you can manage your AWS EC2 instances or the resources. Now, I just go ahead and click on launch instance, or I just click on running instances over here. I hope all of you have access to a free tier account. So this is my free tier account I'm using to do all the hands-on. I click on launch instance in front of you. Okay. Now, this is the page where I can see the AMIs or the Amazon machine image. We discussed the AMI. What's that? It's a template that contains the software configuration, including the application, software, servers, services you want to deploy upon the instance. The main component of the AMI is the operating system, right? Any machine, whether it's a physical machine or virtual machine, should have an operating system upon which you can deploy the software and services. So an AMI is a template, or it's a pre-configured template, which consists of all these different attributes. Now, these AMIs that you can see right now, these are the public AMIs. What do you mean by public AMIs? If you open your free tier account and you sign in, you will see that these are the same AMIs that you can see on my account. You can also see them on your account as well. They're same for everyone. Anyone who has access to the AWS account, any type of AWS account, whether it's business or free tier, you will notice that these AMIs are same. These are public AMIs. These are available to each one of us. Now, these public AMIs we use to test the things for testing purpose, for development purpose. If you want to get your feet wet, you want to get some hands-on. These are public AMIs that you can start using them. In a business environment, you rarely use them, right? You will rarely use these AMIs in the business environment. But yes, for demonstration purpose, for testing purpose, for development purpose, for non-production usage, you'll be using these public AMIs. Chetan, 64-bit is this is the architecture. Like we have two different types of architectures for the operating systems, 32-bit and 64-bit, right? So they differentiate in terms of the resources they have, the capabilities, right? So this is based upon 64-bit architecture. Even on the Windows, you have two different types of architectures, 32-bit and 64-bit. 64-bit is more attuned and it gives you high performance. Fine. Now, these are the public AMIs. As I said before, you will not use them in a production environment. What you use in the production environment is the first thing, which is my AMIs. This is where you manage the customized AMIs. See, customized AMIs means that these are pre-configured AMIs that you use in a production or a business environment. These are the AMIs that you manufacture by yourself and you maintain them so that when you launch your virtual machines or instances through them, all the virtual machines and instances will get the same set of services and applications running upon them. So what's the process? I just show you the process right now. The process is as follows. Now, please pay attention because this is a very important concept for you to understand from the operations perspective and from the exam perspective as well. See, the very first thing is that if you have to manufacture your own customized AMIs or my AMIs, the very first thing you have to do is that you have to pick any public AMI and launch an instance using a public AMI. Okay. Then, in the second step, once you launch your instance using a public AMI, you install everything upon that instance, including your applications, services, software, upon the instance, and you perform some customizations. You customize your software and services depending upon your preference and your taste. So you launch an instance using a public AMI, you install everything upon it, you customize the things, and then the magic happens in the third step. You capture the image from that instance to manufacture a customized AMI. I will show you this process afterwards, but it's really important that you understand the concept first and the demo part will come afterwards. This is a 3-step process that you have to do to manufacture an AMI. And through that customized AMI, you can launch any number of instances of any type, which means that those instances will have the same set of services and applications running upon them. Fine. This is what we discussed in the previous session. Now, you guys have any questions so far? I'm not sure whether all of you have attended the previous session. That's why I recommend that all of you should attend every session, because we continue the previous concepts. But if you have any questions from any of these things, do let me know. I'm going to pause for a few seconds. If you have any questions for me, do put the questions. If you want to speak out, raise the hand. If you want to just type the questions, make use of the question window. No questions from Charles? Okay. Fine. Okay, so I think no questions. All right. No questions? Can you repeat the third step? Okay. So Edmund, in the third step, what exactly we do is that. So the first step, then I think the first two steps are understood. You take the public AMI, you launch instance using the public AMI, you install everything upon the instance, including services, software, and you do the customizations. And then you issue a command, which is create image or capture image. You choose an instance, you go to actions, and you just capture the image from that instance. So what happens is that because that image is customized now, it takes a snapshot of that customized image. Okay, so you have to take the snapshot of that customized image. So this is being done in the form of capture image or create image. Okay. All right. So, guys, any more questions you have, you can put that on the question window. It's really important that you put the question so that if you have even a hint of doubt anywhere, I can just answer those questions for you. So, also we have the marketplace. You can purchase the software from different vendors like Microsoft, Zend, Microsoft, or Amazon, Juniper. SAP, Zend, Microsoft, Juniper, Trend Micro, F5. So you can buy the softwares from these service providers in the form of AMIs. Okay, most of these products or these softwares in the form of AMIs, you have to pay for them. They are chargeable. Community AMIs, as we discussed, this is a developer community effort. You, me, anyone can create an image and publish that in the community AMIs section. Most of them are free of cost. They're used for demo purpose or for the testing purpose. Okay. Now, in my case, I'm gonna go to quick start menu and choose the Amazon Linux AMI, any one of them. Now, if you're using a free tier account, make sure that you choose free tier eligible, so that you don't have to pay for the usage of these AMIs. Okay. I choose select, and this is the instance type. We discussed that. An instance type is nothing but it's the virtual representation of the underlying physical resources. An instance type depicts that how much RAM storage is needed in order for the instance or the applications running upon the instance to work properly. So this is a very common question that people ask me. How do I decide that which instance type is best fit for me? See, the thing is that depending upon the type of services and applications you will be running upon the instances of the virtual machines, you carefully choose the instance type. Because you might have some experience to run those same application services in your own environment. You should know, or you might have some knowledge that what's the amount of resources your applications will consume. For example, you want to buy a fancy laptop, for example, a MacBook. You go to the Mac store, Apple store, and depending upon the type of workloads and the applications you want to run upon your MacBook, you choose the configuration. For example, I want a 64 gig RAM MacBook with graphic cards so that I can run some video intensive workloads. I want to have 2 terabyte of SSD storage, right? So depending upon the type of work I do on my MacBook on daily basis, I will be doing on my MacBook, I carefully choose the specs. Fine. Similarly, depending upon the type of workloads you'll be running upon the instances, maybe a website, maybe a database, maybe any backend application server, maybe a Python web application. Depending upon that, you choose the instance type. And each instance type will give you a certain amount of RAM, storage, processor, and so on. Now, since we're starting small right now, because we have just started afresh, in all our demos, we're going to be using T2.micro as instance type, and you can see the label over here. It's feature eligible, which means that you don't have to pay even a single penny for the usage of it. If you use any other instance type, you have to pay for it. Okay. So I go with the T2.micro as my instance type. I click on next configure instance details. Okay. Now this is where we have to discuss a lot many things, and I'll just try to make sure that I go step by step and explain you each and everything from scratch. Fine. All right. Now, before I jump further to the next level of topic or next concept, any idea what's a VPC? VPC. You can see over here VPC. Any idea about that? You read somewhere, or can you give me the definition? Don't go to the Google and copy and paste the definition. If you have some idea or some knowledge on the VPC, you can put that in one line in your own words. What's the definition about that? The VPC, what's the definition? So Charles, your input is virtual private cloud. Okay. Jatin, private network on our own. Okay, very good. Edmund, virtual private computer. It's a virtual private cloud. Charles, a logical data center. Yeah, you can say that. Logical or a virtual data center. Okay. Any more guesses? Ola, Pedro, you can also give a shot. What exactly you mean by virtual private cloud? Okay. Then another question for you. AWS, is it a public, private, or hybrid cloud? There are three categories of cloud: public, private, and hybrid. In which category AWS falls into? AWS is a public cloud, a private cloud, or a hybrid cloud? Which of the three different categories AWS falls into? Public and private? Okay. There's only one option you have to select. Public, private, or hybrid? Private, I think. Okay. Any more guesses? Public, Charles and Jatin? Are you sure it's public? So you're right. It's a public cloud. Now you may say, how it's a public cloud? It is a public cloud, because what do you mean by public? It's open to all of us. It's open to all of us. Charles, Jatin, Ola, Pedro, Edmund, Rohan, anyone can sign into AWS and start using it. It's a public platform. Anyone can sign up using a credit or debit card and start using it. It's a public platform. So in reality, to start with, AWS is a public platform. It's a public cloud. Okay? It's not private. It's not hybrid. Yes, we can transition it to the private and hybrid in later stages, but to start with, it's a public cloud. That's the reality. Okay? Now, big financial institutions like Citibank or American Express, for example, JP Morgan, let's suppose, wants to deploy the infrastructure on AWS. The biggest hurdle or the impediment or the concern that they will have is that it's a public cloud. Someone can hack to our databases and steal our information, our customers' data. And it's a big concern. So any platform that you choose, be it AWS, be it the Google Cloud Platform, be it the Microsoft Azure, these are the public cloud platforms. Anyone can sign up for their services. Okay? Even your competitor may be using the same platform. Now, this is the biggest concern that most companies have. So how this can be solved? How these things can be solved, or how the security issues can be solved? So these companies, they came up with, they introduced a new term that's called VPC. They said, okay, you want to have some privacy? We give you a virtual data center in the form of the virtual private cloud. So to ensure that you get the same transparency and privacy that you have in your own data center, we give you a private cloud upon the public cloud, which is virtual in nature. What is that? This is a private cloud. This is a virtual private cloud. It's a virtual data center. So it's a virtual data center. Let me just write it down. It's a virtual data center. It's a virtual data center. Okay. It's a virtual data center. Now, this gives you the benefits like, what are the benefits you get out of it? Of course, there will be a separate session on virtual private cloud. It's a 4-hour session. I'll take that maybe in the next month. So what are the benefits you get out of it? Okay. It gives you security. It gives you the isolation. I'll just elaborate all those points one by one. You get more flexibility. More flexibility upon your resources. More flexibility to manage your resources, I would say that. More control upon your resources to make it more precise. You get more control upon your resources. More control upon your resources. And it gives you the transparency. So how this works for you? These are the benefits. How this works for you. Let's imagine we have 3 different organizations. For example, this is my VPC. This is my virtual private cloud. VPC. Okay, let me just write it once over here. This is my VPC-A, which belongs to JP Morgan. Okay. This is my VPC-B, which belongs to General Electric. Right? So let me just write over here. This is my VPC-B, which belongs to General Electric. This is my VPC-C, which belongs to Netflix. I'm just giving you a very small example over here. Of course, we can just take it in a much broader way. Now, these are three different VPCs belong to 3 different organizations. All these virtual clouds, they lay upon the same public platform, that is the AWS public cloud. But from the networking perspective, they've isolated themselves. From the networking point of view, they are being virtually isolated. So JP Morgan will say, I have my own private cloud. Same goes with GE and Netflix. They will have their own private data centers, the virtual data centers on the cloud. Even though they are on the same public platform, but they have logically and virtually isolated themselves from other organizations. So they reap all the benefits of security, isolation. They get more control upon the resources, and they get more transparency into the components of the data center. Okay, so sounds logical. So a VPC is nothing but it's a virtual data center that you deploy upon the same public platform. Every organization, every business unit can have its own virtual private cloud, which gives it the amount of security, isolation. It can get more control upon the resources and more transparency. That's what the purpose of the VPC is. So it eliminates the concern of the organizations regarding the security and transparency. Fine. This is what the concept of VPC is. Of course, there will be a complete 4-hour session the next month on the VPC. I'll discuss the VPC architecture in detail. It's one of the most important topics in the architecture, or if you want to become an architect on AWS, this is one of the most important topics out there. Fine. Okay. So I think you got the basic idea about the VPC. Now, I'll go a little deep into the concepts on the VPC. Just try to get the concepts of it, or just try to pay more attention, because this is what the overview of VPC is. If you understand this concept properly, I'll elaborate this concept in the next month in a 4-hour session or 3-hour session. But if you understand this basic concept, those 4 hours will be much more easier for you to go through. Okay. So I'm just going to give you a basic structure of a VPC. Just try to understand that and let me know if you have any questions. Let's imagine that this cloud is my VPC. This is my AWS cloud. Okay. So this is my VPC, and a VPC is located in a region. Okay. So by the way, do all we have the understanding what a region is? Anyone who doesn't know what a region is, if you still have a slight doubt, let me know. All of you know what a region is? What's a region? If you don't know that, I can just tell you right away, just to ensure that no one falls behind. Okay, so a region is nothing but it's a geographical location. It's a geographical location where AWS has its data centers. For example, this VPC is in Northern California. So it's a geographical location. It's a piece of land on the globe where AWS has its own data centers. Okay. Then what happens is, in this VPC, we carve out something called subnets. By the way, a VPC has a private IP address range. We assign a complete block of private IPs to a VPC. For example, 10.0.0.0/16. Now, don't fall into the details of /16 or the IP addresses scheme. We'll discuss that in the next month. So just you have to understand one thing. A VPC is a virtual data center located in the confinement of a region. What's a region? It's a geographical location. It's a piece of land on the globe where Amazon has its own data centers. You assign a private IP address range to a VPC, and you carve out something called subnets. These two boxes you can see over here, right? These two boxes, let me just label them. What are they called? As subnets. Subnets. Okay. Now I'm laying the foundation for you for the upcoming advanced sessions. Fine. What are the subnets? They are the block of private IPs. Okay, these are the block of private IPs, and they consist of these are the block of private IPs, and they consist of EC2/database instances, any of them. So DB stands for database. So either it can be EC2 or either it can be database instances. So from the networking point of view, you deploy your instances in these subnets. For example, this is my subnet A. Each of the subnet will be linked to an availability zone. For example, availability zone A. Now, some people might have this question, what is availability zone? It's a data center. AZ stands for availability zone. It's a data center. It's a facility. Subnet B By the way, if you have any confusion regarding any of these terms I'm using, do let me know if you have any questions. Subnet B is linked to AZB, availability zone B, a data center B. Okay? And your EC2 instances are contained inside these subnets that are linked to different availability zones. You got the idea? This is how the structure goes. This is the basic structure, the mechanism how a VPC operates. Okay? Any questions you have? And so as I said before, each subnet will be linked to, or it will have a different IP address range. For example, this will have 10.0.2.0/24, and this will be 10.0.3.0/24. Okay. Any questions you have? Because I'm planning we can have a 5-minute break. I don't want to overload you with the information because usually I take a 5-minute break after every half an hour. So but we have passed that half an hour, but I'll just observe a 5-minute break so that I don't overstress you with information. By the way, why I take a 5-minute break after every half an hour? Because as per my experience and the scientific research, an average human being can assimilate just in half an hour of information, beyond which the things get disrupted. Okay, so you can easily get the concept for the first half an hour. After that, a small break should come. Okay, so before we go on a break for 5 minutes, any questions, any doubts you have? Any questions, any doubts you have? Guess one thing you have to understand. As I said before in the previous session, I repeat the same thing. I'll conduct these batches, these sessions 3 times a week. 3 sessions per week I'll be conducting. Make sure that you try to attend all of them because these things are very important for you. Get the most out of it. I know that these are some complicated or complex things, but I'm just trying to make the things much easier for you. Okay. What is subnet? Ajay's question is, subnet is nothing but it's a complete block of IP addresses. A complete block of private IPs. So you can see that there are 2 different rectangular blocks. Each rectangular block is a subnet which has a different private IP address range. Basically, the subnets, they contain your database or EC2 instance resources. And each subnet is linked to a data center, which is called the availability zone. Edward has a question. Can you explain the concept of availability zone again? Okay, so Edward, the thing is that whenever you want to deploy most of the resources, on the right hand side, if you see my screen, you have to choose a region. Okay, a region you have to choose. A region is nothing but it's a piece of land on the globe. It's a geographical location where AWS has its presence. They have the data centers up and running in these different locations, right? A geographical location, it's a piece of land on the globe. So, for example, they have few data centers in Mumbai, in India, in Hong Kong. They have few data centers in North Virginia, Ohio, California, Oregon, Paris, Stockholm, Ireland, Frankfurt, Canada, and so on. So they have set up their data centers in different parts of globe. So a geographical location, it gives you an idea that AWS will have at least 2 data centers running in that piece of land. That's a region. Those data centers in these different locations or regions are named as the availability zones. The data centers in these regions or different parts of globe, those data centers are called AZs or availability zone. Okay, that's what it means. Fine. Guys, any more questions before I can get ahead with some more concepts for you? No questions, no doubts? Okay. Okay, so let's do one thing. Let's go further now. So the thing is that on the third step where we have to configure instance details, I can choose the number of instances I can deploy in any single shot. Okay. By the way, there's one question for you, just to test your knowledge. How many number of instances we can launch parallelly at any given point of time in a free tier account? Or I would say in any account that you have started afresh, how many on-demand instances you can run? Which means that you're being built based upon the number of hours. How many number of on-demand instances you can run in any account? 2, 10? It's actually 20. 20 on-demand instances you can run in any account. Up to 20. Okay. Now, the thing is that this means that if I want to have 20 instances to run parallel at the same time, I can do that. If I make it 21, then it will only allow me to have 20 instances up and running on demand instances. What do you mean by on demand? On demand means that you are being charged based upon the number of hours consumed. Of course, in the featured account, you are being subsidized. You get 750 hours free for Linux instances, plus 750 hours free for Windows instances per month. Beyond which, you are being charged for each hour your instances consumed. Okay. So purchasing option, I'll stick to on demand and make it as only one instance. Network. Now we discussed the concept of VPC. Now VPC is a networking component. So this is the VPC which is located in the region of Mumbai, because right now the region I'm using is Mumbai. So the network I use, this is my default VPC, and these are 3 different subnets linked to 3 different data centers or availability zones in Mumbai. Okay. What's a subnet? It's a complete block of private IPs which consist of my instances. For example, I pick the first subnet which I've highlighted, 372C84C. If I deploy my instance or choose a subnet, my instance will be launched in this availability zone or data center, AP South 1C. If I choose a second subnet, in that case, my instance will be deployed in availability zone, AP South 1P. If I choose a third subnet, my instance will be deployed in AP South 1A, data center or availability zone. So AP South 1A, B, and C on the right hand side, these are 3 different availability zones. Okay. Now, what AWS recommends is that you choose no preference and you leave it to us. We can automatically choose the best data center for you and choose any one of these 3 different options. But it's up to our discretion. We can impose our own preference saying, okay, I want to deploy my instance in the subnet linked to the data center or availability zone, AP South 1A. Okay. Now, you can also choose the default setting, which means that your instance will get the public IP address automatically. So from the network and subnet range, the instance will get the private IP. And upon that, you can also enable this setting, which means that your instance will also get a public IP as well. Okay. Placement group is an optional item. You can go for that on if you want, you can skip it. We'll discuss placement group in a separate conversation. Capacity reservation means that you want to reserve this instance capacity for a duration. I would say no. Okay. IAM role. Now this is a bit, I would say, off the track topic, but we'll discuss IAM role in some other session. Basically, the concept of IAM role is that you allow the instance to communicate with any other service in AWS infrastructure. For example, let me do one thing. Let me just give you one example. We'll have a separate discussion on IAM role in some other session, because this is a very vast topic, IAM. By the way, anyone knows the full form of IAM? If you've gone through it in your free time, IAM, what does it stand for? You can make a guess. if you want. Yeah, identity and access management. Great. Thanks, Jatin. See, the concept of IAM role is, of course, there will be a separate discussion on the IAM maybe next week. I'll see that if I can just discuss that. So the IAM stands for Identity and Access Management. IAM role means that, I'm just giving you one example. It's a very broad topic, but I'm just giving you an example to simplify it. Let's imagine you have this EC2 instance upon which you're running a WordPress site. I'm just giving you one example. Just try to understand the basic concept. So this is my WordPress site. Sorry. Now, I have my internet users. These are my external/internet users. Okay. They want to, you have deployed a WordPress site, like it's like an Instagram kind of website. They push or they upload their images to your WordPress site or the application running upon the instance. Those images are further pushed and stored in a storage option we use in AWS. It's a very popular storage option. You might have heard about it. It's called an S3 bucket. So these images are being further stored into a different storage option. It's a storage. It's I would say it's an object or based storage. We'll have a separate conversation on S3 some other time. And so these images are being pushed and stored in the S3 bucket. And when the users want to retrieve them or pull them back, so they can pull the images back and download them. Fine. Now, what happens is that if you see behind the scenes, my EC2 instance or this WordPress site is communicating with the S3 bucket to push or retrieve the images. In a normal situation, this type of conversation is not feasible. So to make that feasible, you have an IAM role that you assign to the EC2 instance. And this IAM role has some permissions attached to it. For example, the permission is Amazon S3 full access. Okay, this is a permission so that this instance or the WordPress site running upon instance can push or retrieve the images from the backend S3 bucket. Now, you don't have to stress upon this point too much right now because I have a different lecture on IAM maybe in the next month. I'll elaborate this point in detail for you afterwards. So you want to have the services or applications running upon the instance to access another service automatically. So you assign the permission to that instance that, okay, I give you the permission so that you can access the bucket or the S3 bucket to put or get the images from it. Okay, this is the concept of IAM role. Now, this concept is very broad. I'll discuss this concept with you in detail afterwards. Okay, so I just go back to my instance dashboard, and as of now, I just put it to none. I don't want to go in details as of now. Just keep it simple and minimal. So I will just set it to none. Shutdown behavior means that if you shut down the instance, what do you want? Do you want to stop or terminate? By the way, any idea what exactly, if I terminate the instance, what happens? Just a kind of input from you. If I terminate the instance, what exactly happens? It releases? Yeah. So if you terminate the instance, it's permanently gone. Terminate means that you kill the instance. It goes away. Okay, you can't get it back. Any terminate terminated instance, you can't get it back. But if you stop it, which means that you keep that in suspended state, you can always come back and start it again without losing anything. Okay, so I want to go over the default shutdown behavior, which means that if I shut down instance, it gets stopped so that the next time I log in, I can restart it. Okay. Now, if you terminate the instance, it's permanently gone. So I can immune this instance from accidental termination so that no one can by mistake kill or terminate this instance. Because if someone, let's imagine this instance is a master server in my Hadoop cluster. Let's take into this assumption. This instance would be my master server in my Hadoop cluster. If this goes away, my entire cluster would be impacted. My entire operations would be shut down. So I immune this instance from termination so that the terminate option is grayed out. I'll show you that how it looks like. I disable the terminate option temporarily. That's what I'm doing. Okay, got the point? Now, the next thing is monitoring. CloudWatch. What is CloudWatch? See, CloudWatch, there will be a separate conversation on CloudWatch some other time, but I'll just give you some of the basic details on it. If you want to give the SysOps exam, CloudWatch is a topic from where you get many questions. Fine. So what is CloudWatch, by the way? Let's understand that. See, CloudWatch is a default monitoring tool. From AWS perspective, what's that? It's a default monitoring tool. It's a default monitoring tool. Most of your resources in AWS would be monitored by CloudWatch. It can be your instance, your database, your volumes, your auto-scaling groups, your clusters, the containers, load balancers. Most of the resources will be monitored by this service. Now, the thing is that how this works for you. I'm just giving a basic understanding. Just try to get the basic concepts first. Let's imagine this is your EC2 instance. And this has to be monitored. Now, why do you monitor the things? To get to know that how they're functioning. Are the resources functioning as per your expectations? Or they're functioning some other way? So you want to analyze or gauge the performance of a virtual machine. That's an EC2 instance, right? CloudWatch is an external entity that you use it. External means that, of course, it is an AWS resource, but it's not a client software running upon the instance. It's a separate entity. First thing first, before this instance is being monitored for its performance, this instance will push the metrics. It will push metrics. What are metrics? You use the metrics. These are the parameters against which you analyze the performance of the instance. These are the parameters used to gauge performance. Okay. For example, I just give you one example right now. So let's take an example. CPU utilization. I want to get to know what's the CPU usage or the CPU utilization of this instance. So instance will say, hey CloudWatch, this is my metric, CPU utilization. For example, you want to gauge the length and breadth of your table. Use millimeters, centimeters, right? Those are the parameters. And similarly, CPU utilization is one of the parameters against which I can get to know that how my instance is performing. Now, the CloudWatch once it gets the metrics to gauge the performance of an instance, it will perform the health check every 5 minutes by default. Okay? And it will retrieve the metric along with the value. For example, this is my metric, which is CPU utilization. And presently, the value for this metric is 70%. So you as an admin, you can log into the CloudWatch and see, okay, I see as if now my instance is performing at 70%. The CPU performance, the CPU usage is 70%, to be precise. You get to know the exact performance of that virtual machine in real time. So the frequency is 5 minutes, which means that every 5 minutes, the CloudWatch will ping the instance at the backend and get its metrics and the value of it. This 5-minute frequency, it comes under standard monitoring. What's that? It is standard monitoring, which means that it will gauge or analyze the performance of the instance every 5 minutes. This is a question that comes in the exam frequently. Standard monitoring, which means that every 5 minutes by default, this is a default option. Your instance will be gauged for its performance, and this is free of cost. You don't have to pay even a single penny for this type of monitoring. Okay. The second type of monitoring is detailed, which means that you increase the intensity from 5 minutes to a minute, the frequency of which is 1 minute, and you have to pay. So this is chargeable. You have to pay for it. It's not free. So because you're increasing the number of communication streams between CloudWatch and instance, it will utilize more bandwidth. So in that case, for detailed monitoring, which means that every 1 minute, the CloudWatch will ping the instance and get the stats out of it. You have to pay for it. This is a question that comes in the exam very often. Okay. You might be asked about the frequency of the standard monitoring or the detailed monitoring. And even though it's very basic, most of the times you get a question in the exam. Fine. Okay. Now I just go back right now. If I keep this option unchecked, enable CloudWatch detailed monitoring, in that case, it remains standard, the frequency of which is 5 minutes. If I check this option, the frequency becomes a minute. For that, I have to pay additional charges. So I'm going to uncheck this option. Okay? Got the point? Now, the next thing is that I will just I'll choose the tenancy. Fine? I choose the tenancy. See, there are two types of tenancies that you have to discuss. I'll discuss these basic things and then we'll see what we have to do next. See, tenancy means that how exactly the instances are running on a virtual machine, on a physical machine, right? You might have heard about the virtualization, virtual machines. Now, virtualization was first coined, or I would say it was made popular by the VM. I would say VMware or the hypervisor. VMware ESXi was one of the popular hypervisors, and it was made popular at that time, almost more than a decade ago. So virtualization came into the picture because now you can run multiple machines on a single physical machine. So for example, let's imagine. So what happens is, how this works for us. Let me just discuss with you. It's a basic concept. So for example, in a normal environment, if you don't have any virtualization, This is a physical server. This is a physical server. And it can be HP, IBM, or Dell physical server. Okay. Now, the thing is that previously, before virtualization was introduced or came into inception, only one operating system, only one OS can be installed upon it. Okay, so it was quite limited in nature. After virtualization, the things changed. On the same physical server, you can run multiple operating systems and workloads. So after virtualization, you use the physical server to the maximum potential. So this is the same physical server. This is the same physical server. This is the same HP, IBM, or Dell physical server. Okay. You run upon it a hypervisor. It's a client software that you run upon a bare metal. It's a client software. And this hypervisor, the client software, helps you to launch virtual machines of different operating systems with different workloads running upon them. For example, these two machines can be running your Windows Server 2016. This can run Ubuntu operating system. These two can run Red Hat, Linux operating systems. So can you see that things changed in past a decade? On the same physical server, only one operating system can be deployed. On the same physical server, multiple virtual machines can be deployed, which consist of different flavors of operating systems with different workloads running upon them. Okay, this is how we transitioned into the world of virtualization. Okay, now from the AWS perspective, let's take it further now. AWS has two different types of tenancies. Okay, by the way, any idea that which hypervisor is used by AWS? The hypervisor used by AWS is Xen, XCN. This is the flavor of hypervisor used by AWS on their machines. Okay. Now let's imagine. Okay, let's discuss the tenancies. There are two types of tenancies we use in AWS. One is shared. Shared means that on the same physical machine, you have different virtual machines up and running that belong to separate individuals or organizations. For example, let's imagine this is my HP, IBM, or Dell physical server. Okay. Of course, this is my Xen hypervisor. This is my Xen hypervisor. I'm just making it simple. Of course, you have different layers upon the physical machine, but the main component that you deploy upon the physical machine is the hypervisor. Now, these are small instances of the virtual machine. I'm talking from the hardware perspective. On the same physical machine, these are the instances. These are what? These are your EC2 instances on the same physical machine, but they might belong to different or separate individuals and organizations. For example, these two belong to JP Morgan. This instance of the machine, virtual machine, belongs to Wipro. Okay. This belongs to Charles. He owns it. This belongs to me. I own it. So can you see that? On the same physical machine, you have different virtual machines running, or the EC2 instances running, that will belong to different organizations or individuals. Of course, they are being isolated so that there's no direct intervention, but still, this exists. You can use it without any compromises in terms of security, and this is free of cost. For this tenancy, you don't have to pay for it. Okay? For this tenancy, you don't have to pay for it. But sometimes you are not comfortable running your instances on the same physical machine. You don't want to share the physical machine with other people. So in that case, you pay some extra charges and you go with the dedicated tenancy. In the dedicated tenancy, this is the same physical machine. This is the same HP, IBM, or Dell physical server. Okay. You have the same Zen hypervisor running upon it. But these machines all will be yours because you will say, okay, this is mine. I own it. You pay for that. You pay extra for the entire physical server because you're occupying the entire server. Okay. And all these machines will be mine. I pay extra for it, but I will not allow anyone running their machines on the same physical server. Okay. Now, this is feasible if you have some special software requirements. For example, the Oracle Enterprise Edition database can only be deployed on a dedicated tenant physical server. So example is Oracle Enterprise database. It doesn't support shared tenancy. Also, some security, compliance, or legal requirements. It doesn't allow you to run the machines on the same physical server. Virtual machines or the instances on the same physical server. Okay. In that case, you can pay extra and you can go with the dedicated tenancy. Fine. Okay. So by default, I just go ahead and choose shared. If you have some extra money, you can go with dedicated. But I'll go with the shared. If I go with the dedicated tenancy, I have to pay extra charges. Then we have T2, T3 Unlimited. This is just to burst the performance if it needs more resources behind the scenes. Usually we don't use it. We're going to skip it. File system, we can add on elastic file system, which is scalable in nature, and that can be shared across multiple instances. As of now, we're going to skip it. Network interface, every instance gets an interface. This is the virtual network interface. We're going to keep it as it is. Under advanced details, I can put the script so that I can install upon the services upon the instance when it boots. Okay, I'm going to skip it as of now. So these are the details that we've discussed on the step 3. Okay. So guys, that's about the third step. Any questions you have? Jatin is saying, do we have available codes of agent installed for cloud monitoring? Yes, it's available, but it's third party. You can also have some third party monitoring tools included in AWS. For example, SolarWinds, NetGeos. Yeah, you can include those third party monitoring tools in AWS, but of course you have to pay separate charges for that. Fine. Guys, that being said, I think I should stop right now. It's too much of the information for us to assimilate. I will stop right now. We'll continue this conversation in the upcoming Monday. On Monday evening, I'll take on this thing and discuss with you further now.